Hello everyone, welcome to another episode of Math-221. So today we're going to go over section 12.1, which is formal languages and regular expressions. So a little bit about why we're studying this topic. Formal languages and regular expressions form the basis of theoretical computer programming languages and also how compilers work. They're also really important in text processing and searching. So if you're a computer science student, then you'll definitely be hearing more about this topic in the future. And particularly if you study compilers or probably in database studies as well. If you're a math major, then this might be the last time you hear about this topic, but it's quite interesting anyway. So let's get into it. Okay, so first of all, we have some definitions. So firstly, we have an alphabet, which is going to be denoted by the capital sigma. And that's just a finite set of characters. They could be letters or numbers or anything really. And then we have a string over the alphabet sigma. That is either a finite sequence of elements, which are called characters of sigma, so they have to come from the alphabet, or it can also be the null string epsilon. So the null string is just an empty string. It is still an object, it's a string, but it just doesn't have any characters in it. And then we have the length of a string over sigma, so that's just simply the number of characters that are in the string, and then the null string has a length of 0. And then we have a formal language over sigma, so that is a set of strings over the alphabet that someone defines for you, or you can define it yourself. It's just a set of strings. So note here that epsilon, that is the Greek letter epsilon, and that should not be confused with the element symbol. They do look quite similar. In fact, I believe that the element symbol actually used to be an epsilon, but then it sort of evolved into its own symbol. So try to keep those separate. Okay, so let's look at a few basic languages, and remember that a language is just simply a set of strings over the alphabet. So let sigma be an alphabet. Then for each non-negative integer n, we have the following three languages here. So we have sigma n, so that is the set of all strings over sigma that have length n. And then we have sigma plus, so that is the set of strings, all strings over sigma that have length at least 1, so they have to have a positive length. So this is obviously the second one here, that is an infinite set, so there's infinitely many strings that you can make with your alphabet if they're just going to have a positive length. And then finally we have sigma star, and that is the set of all strings over sigma. So sigma plus and sigma star are quite similar. The only difference really is that sigma star includes the empty string. So that's the only difference between those two. There's also a little bit of terminology here, which is not too important, but I'll just mention it. Sigma star is called the clean closure of sigma, and then sigma plus is called the positive closure of sigma. And that clean there is, that is somebody's name that came up with that originally. Okay, so let's look at an example here, and maybe it'll make more sense. So our alphabet here, sigma, is just going to be the set of x and y. So x and y are the characters we're going to use to make these strings. So number 2, part A, let L3 be the language consisting of all strings over sigma of length less than or equal to 3, in which all the x's appear to the left of all of the y's. List the elements of L3 between braces. Okay, so let me go ahead and do this. So to do this systematically, I'm going to start with the smallest string, or the shortest string. So the shortest one would be epsilon, the empty string. Okay, so this is the empty string. Alright, so that's length 0. So 0 is less than or equal to 3, so we can include that one. Now, they never said that there did have to be both x's and y's. They just said that the x's have to be to the left of the y's. So I think we can have strings here that are all x's. Okay, so then for my length 1 strings, I'm going to have an x and then a y. Okay, so both of those have the property that all of the x's are to the left of the y's because neither of them has both x's and y's, so we don't have to worry about it in that case. Then for the length 2 strings, we can have xx. We can have, okay, so the x's have to be to the left, so we can have xy, but we cannot have yx because that would fail the condition. And then we can also have yy, okay, because that doesn't have any x's, so we don't have to worry about the condition. And then we can also have the length 3 strings. So let's see, we can have xxx, and then we can have xxy, and then we can have xyy, and then we can have yyy. So I believe that's everything. So there are some things that we can't have, like for example, we can't have xyx because that would not have all the x's to the left of the y's. All right, let's do part B here. List between braces the elements of sigma 4, the set of strings of length 4 over sigma. Okay, so let's give this a try. Oops, I'm sorry, I'm already writing it incorrectly. So this is going to be sigma 4. Okay, so the length 4 strings, we can have the one that's all x's, and then the x's always have to be to the left of the y's, so we have to start putting y's at the end. So we can have 1y at the end, or we can have 2y's at the end, or we can have 3y's at the end, or we could have all y's. Okay. All right, so here is a homework problem for you to try. So go ahead and give this a try, and then check your answers in the back of the book. Oh, and just to mention a palindrome, that means it's symmetrical from left to right. So like x, y, x, for example. Okay, now let's talk about combining languages. So let sigma be an alphabet. Given any strings x and y over sigma, the concatenation of x and y is the string obtained by writing all the characters of x followed by the characters of y. So you basically just put them next to each other. For any languages L and L prime over sigma, 3 new languages can be defined as follows. So the concatenation of L and L prime, denoted L prime, is this. So it's just the language where you take everything that is in the first language and everything in the second language and you just concatenate them like that. So you concatenate anything from L or L prime. Then there's the union of L and L prime, which is exactly what it sounds like. It's literally just the union of those two sets. So it's anything that is in L or in L prime, or in both of them. And then finally we have the clean closure of L, which is denoted L star. And that is, so that one's the biggest one, I think. That is a concatenation of any finite number of strings in L. So you only need one language to do that, and then you just take anything that's in the language and you can concatenate. You can concatenate 2 things together, you can concatenate 3 or 4 or 5 or any number of things that are in L, you can just stick them together. And you can also concatenate things just once, so like everything that's in L will also be in L star, because if you concatenate something once then it's just the original thing. And then also note that epsilon, the empty string, is in L star because that's regarded as a concatenation of 0 strings. So if you concatenate 0 strings, you're not sticking anything together, so then you get an empty string. Okay, so let's practice with these a little bit. All right, so let's look at this example. We're going to describe L1, L2, L1 union L2, and then L1 union L2 star for these languages L1 and L2 that are described. So L1 is the set of all strings of A's, B's, and C's that contain no C's. Okay, so it's just A's and B's, I guess, and have the same number of A's as B's. L2 is the set of all strings of A's, B's, and C's that contain no A's or B's. Okay, so L2 is just C's. Okay, so let me just kind of like break that down a little bit more. So L1 is the set of A's and B's that have same number of A's and B's. L2 is just C's. Okay, so for L1, L2, we're only putting things from L1 in the front, and then we're putting things from L2 in the back. So this is going to be the set of strings that start with a string of A's and B's where there are the same number of A's and B's. So that's something from L1. There are, sorry, I lost track of what I was writing there. The same number of A's and B's, and end with any number of C's. Okay, so that's L1, L2. So you stick something from L1 in the front and then something from L2 in the back. And then for L1 union L2, that's just anything in L1 or in L2, is this is the set of strings that are either entirely A's and B's with the same number of A's and B's, or any number of C's. So you can't combine A's and B's, but you can have all A's and B's with the same number of them, or you can just have a bunch of C's. So the hardest one to think about is the clean closure, the L1 union L2 star, because in that one you're allowed to take anything from L1 union L2 and you can stick it together as many times as you want. So you can take any number of elements from in there and string them together in any way that you want. So it's a little bit tricky to think about what might be in there because there's so much stuff that's in there. So for example, you could have some A's and B's, and then you could have some C's, and then you could have some more A's and B's, and then some C's. Or you could just have a bunch of A's and B's if you only took things from L1 and strung them together. So really you can have your C's in there anywhere you want because you're allowed to concatenate them in any order that you want. So I think this is just going to be the set of strings of all A's, B's, and C's and C's. And I think the only really distinguishing property that this set is going to have is that you'll always end up with an equal number of A's and B's, because every time you take something from L1 and concatenate that in there, you'll keep having that property. So I'll just write that. Okay. All right, let's do another example. So L1 is the set of all strings of zeros and ones that start with a 0, and L2 is the set of all strings of zeros and ones that end with a 0. Okay, so then L1, L2, so we're putting things from L1 in the front and things from L2 in the back, and we can only do one thing from each set. So this is going to be the set of all strings of zeros and ones. So the one in the front is going to start with a 0. And the one in the back is going to be from L2, so that's also going to end with a 0. So when you concatenate those two, it'll start with a 0 and end with a 0. Okay? And then for L1 union L2, you're taking something from L1 or something from L2, and you're not concatenating at all. So this is just going to be the set of all strings of zeros and ones that start with a 0 or end with a 0, or both. So it could be both, because there could be things in L1 and L2 that do both. All right, and then for L1 union L2 star, so this is the hardest one to think about. So you're allowed to take anything from L1 union L2, as many things as you want from there, and just concatenate them together in any order that you want. So you're not necessarily going to have zeros in the front or the back anymore, because you're concatenating together these things in any order. So it's really difficult to think about what distinguishing property this set might have. I think the only thing I can really think of is that I don't think the empty string is in either L1 or L2, because you do have to start with a 0 or end with a 0. So things that are in L1 or L2 are things that have at least one 0 in them. So then when you do the clean closure of that, I think all your strings are going to have at least one 0 in them. And that's about the only property I can think of that would actually distinguish this. So I'll just write that. There might be something more to it than that. I'm having a little trouble thinking about it. I keep pausing the video thinking about this. Okay, I'm just going to move on anyway, though. All right, so here is the homework problem for you, and go ahead and give this a try and check your answer in the back of the book. All right, so now let's talk about regular expressions. So these are quite interesting. So given an alphabet sigma, the following are regular expressions over sigma. So first of all, we have the base cases. So the empty set is a regular expression. The empty string, which is different from the empty set, is a regular expression as well. And each individual symbol in sigma are also regular expressions over sigma. Okay, and then comes the weird part. So you're allowed to combine other regular expressions using 3 different operations. And because you're allowed to combine these, you can combine them multiple times and they can get really, really complicated. So recursion, if R and S are regular expressions over sigma, then the following are also regular expressions over sigma. So the first one there, number 1, RS, that is the concatenation of R and S. So you put R in the front and S in the back. And remember, R and S are regular expressions, so they could be like kind of complicated. They might not just be one symbol. And then number 2 there is R or S, so with the vertical line between them. So we've used the vertical line to indicate 3 different things in this class. We've used it for divisibility. We've used it in set builder notation to stand for the phrase such that. And now we're using it in a third way here. So this time, this little symbol right here, this means or. Or. Okay. So R or S, that indicates either the string R or the string S. And then finally, number 3, R star. So that is again the clean closure, and that indicates that you can repeat the string R as many times as you want. You can concatenate it with itself any number of times that you want to do, including 0 times. Okay, and then the following, the last part there, restriction, is that nothing else is a regular expression over sigma except for the objects defined in 1 and 2 above. Okay, so that was all pretty abstract, so let's actually get into some examples. But I think we need to do something before that. So the last thing we need to do before we look at some examples is to talk about the order of precedence. So because we're able to combine regular expressions in really complex ways, there needs to be an order of precedence for the operations that we talked about on the last slide. So, and we're also going to be combining parentheses with these to indicate places where we want to do something other than the order of precedence. So the parentheses are going to function just like they do in regular arithmetic. So anything that is in parentheses will be evaluated first. And then the second thing that you'll evaluate is the star, the clean closure. And then the third thing is concatenation. So if you have 2 things that are just written right next to each other, that means they're being concatenated. And then the fourth thing will be the or symbol. So this is our order of operations, and the way you can think of this is like the star is kind of like exponentiation. That's the thing that goes first in the arithmetic order of operations. And then concatenation is kind of like multiplication. Obviously the operation itself is not like multiplication, but just in terms of the order of operations. And then the or thing is kind of like addition. So in terms of your regular old PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction order of operations, this is the same kind of order here. So star first, concatenation next, and then or is last. All right, so let's look at some examples where we talk about the order of precedence. So these are all regular expressions, and as you see, they're quite complicated. So what we're going to do is add parentheses to make the order of precedence clear in these given expressions. So I'm going to do number 8 and 9, and then number 7 is your homework problem. Okay, so let's look at number 8. Okay, so we have 0 star, and then 1, and then or, and then 0, parentheses, 0 star, and then 1, and then a star outside of the parentheses. Okay, so the first thing in the order of precedence is the parentheses. So everything that's in the parentheses there will be evaluated before the other things. And then the star on the outside of that means you can repeat the entire contents of the parentheses as many times as you want. So the first thing I think I'm going to put the parentheses around is the things that have stars, because that's the next in the order of operations. So I'm going to put the 0 star in parentheses like that, and then I'm going to have this 1, and then there's an OR, and then there's a 0, and then I'm going to put another parentheses around this 0 star, like that, and then the 1, and then the star. Okay, so anything that's written right next to each other, that is concatenation, so that is the next thing in the order of operations. So the things that are being concatenated, I'm going to put parentheses around them. Okay, so the things to the left of the OR symbol are being concatenated. So I'm going to have that's being concatenated in those parentheses there. And then I have the OR, and then I have 0 is being concatenated with everything in this set of parentheses over here. Okay, and then I think that's good. We could put one set around the whole outside of the whole thing, but we don't really need that. So I'll stop there. All right, then for number 9, this one is even longer. So let's see, I'm going to go through and I'm going to do the stars, the things that are being starred first. The YZ one over here that has the star on it, that already has its own set of parentheses, so I don't really need to do it there. So I'm just going to put a parentheses around there, around that Z like that. So this will be X or Y, V star, and then Y, X, or, so the rest of it I'm just copying it. Okay, so the next thing in the order of operations is the concatenations. So things that are being concatenated, I'm going to put parentheses around them next. So let's see, this Y and this Z star are being concatenated. And then over here, this YX is being concatenated, so that's being evaluated next. And then on the other side of this OR, everything over there is being concatenated as well. Okay, so that's my order of operations there, and I'll stop after that. All right, so number 7 is your homework, so go ahead and try doing that one, and then check your answer in the back of the book. Okay, so now let's go in the opposite direction. So we're going to eliminate unnecessary parentheses in these using the order of precedence or the order of operations. Okay, so I'm going to do number 11. So let's see. I think I see the 1 star, the 0 star, and the other 1 star are surrounded by parentheses, and we don't actually need those to be around them because we know that star goes first. So those will be just fine without the parentheses. Okay, so I'm going to take away those, and then, wow, this is fairly complicated actually. Like getting a little bit cross-eyed trying to look at all these parentheses. There's 1 there, and then over here, that'll be 1 star 1. Okay, and then, okay. All right, I think I got it all there on the first sweep. And then to go through again, the next thing in the order of operations is concatenation. So these things are being concatenated here and here and here, so they don't need parentheses around them either. So I can eliminate those. So this will just be 1 star, and then OR, and then over here this is, so I still need 1 set here I think, but then the inside, oops, meant to take that one away. Then the inside ones I don't think I need. Okay, so it'll be like that. And then they haven't told me whether this OR operation is associative or not, so I feel a little uncomfortable taking away that last set of parentheses, even though I think OR is probably associative. So I'll leave that last set there. All right, then for number 12. Okay, so I'm going to go through and take away the ones that are just around something being starred first. So this will be X, Y, and then 2 sets, and I'll take away the 3rd set. And then there's a Y, and then there's 1 more, and then another star, and then 1 more. Okay, and then the OR, and then I'll do these 3, YX, or Y. All right, and then I'll take away the ones around the Y star here at the end. Okay, and the next around things that are being concatenated, I'm going to also take them away because that's the next in the order of operations. So this will just be xy by itself. And then inside here, I'll have x star. Oh, so I do still need the ones that are around x star, y star for that star to go to both of the things in the parentheses there. Otherwise, it would just go onto the y, which is not what the person who wrote this wants. So then I'm going to have the or, and then here, I think we can drop a couple sets here, and it's just going to be, oh gosh, this is fairly complicated actually. So we're going to have y, x, or y. I think that still needs parentheses around it, and then just y star. Okay, I think I've done it. All right, so you guys go ahead and try number 10 and then check your answers in the back of the book. All right, so now let's talk about the language that is defined by a regular expression. So if we just had regular expressions, they don't appear to actually do anything other than exist. So we need them to actually do something. And the thing that they do is that they give us a language. Okay, so the language that is defined by a regular expression is all of the strings that can be made from that regular expression. So let me tell you what those are. So for the base cases, if your regular expression is just the empty set, then the language is empty. There's nothing in it. And then otherwise, if your regular expression is just one symbol, whether it's the empty symbol or whether it's something in the alphabet, if it's just one letter from the alphabet or the empty string, then you just get that particular string in your language. And then otherwise what you get is the following. So whenever you have two strings that are concatenated together in your expression, that means that you're concatenating the two languages that come from those strings. So whatever you get from the first regular expression, you can concatenate with whatever you get from the second regular expression. And then when you do the or symbol between two regular expressions, that means that you are unioning the two languages that come from those regular expressions. Okay, so whatever strings you get from whatever's on the left side of the or, you can get either that, or you can get the strings that you get from whatever's on the right side of the or. And then finally for the star, if your regular expression has a star, you're doing the clean closure or the star operation onto that whole language. So you are allowed to concatenate together as many times as you want anything that comes from that regular expression R. So this is, again, fairly abstract and kind of complicated. So let me show you some examples that I hope will make it make more sense. All right, so let us look at these examples here. So I've placed up here the definition on the last slide, and it says here for us to use set notation to derive what the language is here. So that's exactly what I'm going to do. I'm just going to put in the sets exactly from the definition, and then as we kind of progress through the lesson, hopefully it'll become more natural to you to see what these regular expressions mean in terms of strings. But we'll start with this basics from the definition. Okay, so I'm going to do number 14 first. So what I want is the language that is defined by this regular expression. So I'm going to place it in the L parentheses like that. So I want its language. And then what I'm going to do is I'm going to use this part 2 of the definition right there to split this into a union. So this is going to be the union of the language defined by the empty set and the language defined by the empty string. Okay. And then what I'm going to do is for each of those, I'm going to use this part up here to replace those with what they equal. So the first one is just going to be the empty set. And then the second one is going to be the set containing the empty string. Now, when you union the empty set with anything, it doesn't add anything to the union. It doesn't bring anything to the table. So this is just going to be the empty string, the set containing the empty string. And that's it for 14. So let's go ahead and try 15. So for 15, so you want to look in the order of precedence. So I have the outermost, or kind of the last operation here is the concatenation between A or B and C. So I'm going to start breaking it down from that point. So I'm going to start with just putting the whole thing into my L thing here. So I want the language that this represents. Okay, and then I'm going to break it down like this. So first I'm going to have, I guess I can take away the parentheses at that point. So this will be A or B, and then L of C. Okay, so that's using this rule right here. All right, and then I'm going to use the second rule right here to break down the first one. So this is going to be L of A union L of B, and I'm putting parentheses around that because I want to evaluate that before I concatenate it with L of C. All right, so now at this point I've just got one symbol in each of my languages, so that's just going to be the language containing that symbol alone. So that's the only string that I get there. And then I'm going to concatenate that with the set containing the string C. Okay, so what do I get for the first one here? This is just going to be A comma B. That's how we do a union. And then I'm concatenating that with C. So I said at this point I don't really need the parentheses anymore. All right, so now I'm going to concatenate A or B with C, and I'm going to get AC and then BC. Okay, so basically what you end up getting, starting from the original expression, it's either A or B concatenated with C, and you see the end result that you end up there with is either AC or BC. So those are your two possible strings that you can get from that regular expression. Okay, so go ahead and pause the video and try number 13, and then check your answers in the back of the book. All right, so now let's try going at a little bit of a faster speed. So I'm not going to use the formal set definitions that we were doing on the last slide. I'm just going to kind of like go right at this thing and try to write some strings that belong to the language defined by the regular expressions. Okay, so for number 17, so looking at what I have here, I have this or thing in the middle. So that means that I can either do something that comes from this regular expression, or I can do something that comes from the regular expression on the right there. Okay, so this or this. All right, I can pick between those two things. So if I do the one on the left, so using B star, I could get the empty string if I don't concatenate it any times, or I could get B, or I could get BB, or I could get BBB. I can just keep concatenating that as many times as I want. Okay, and then using the one that's on the other side, B star, A, B star. So I could get, so the only thing I have to do is put some B's, and then I have to put one A, and then I have to put some more B's. Okay, so I could just get A, because I don't have to put any B's. When you have the B star, you can put 0 B's. Or I could do B, A, B, 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 A, B, 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 A, B, B, B. And you don't have to do them the same number of times either. You could do like B, A, B, 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 or B, 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 A, B. Or you could do like one of them 0 times and the others a few times. You can just keep going like this all night. I mean, till infinity. You could list infinitely many strings that fit this regular expression. Okay, so all of those are in the language defined by the expression in 17. So it's kind of fun, actually, once you get the hang of it. All right, then for number 18. Okay, so it has to start with some number of x's, and then we have to do the thing that is in the parentheses there. So I could start with 1x, and then I could do, well, I don't need the parentheses. So I could do 1x, and then I could do the thing on the left side of the or, so I could do y, x, x, y, and then I'm allowed to repeat that y, x, x, y thing as many times as I want because of this little star that's on the outside there. So I could do that more than once. I could do like a few times. Could do it 3 times if I want. however many times you want. Or I could do, you know, like a couple x's in the beginning and then y, x, x, y. I'm just doing like way more than 5, but I just want you guys to understand this. I could do 3 x's in the beginning because x has a star, and then I could do y, x, x, y, and then another y, x, x, y if I want. So that was all using the thing on the left side of the or here. If I want to use the thing on the right side of the or, over here, I can just do x as many times as I want. Or you can also like alternate in between these two things that are on either side using the star right here. You can do multiples of either one of them in whatever order you want. So for example, I could do like some x's at the beginning, and then I could do y, x, x, y, and then I could do some more x's from this x right here. And then I could do another y, x, x, y, and then I could do some more x's, and you can just keep going like that into infinity. So I hope this makes sense to you. It is a little bit strange, but this is the basis of computer compilers and programming languages, actually. Alright, so go ahead and pause the video and do number 16, and then check your answers in the back of the book. Alright, so on this examples here, we're going to use words to describe the language defined by the given regular expression. So we're going to try to kind of encapsulate what the entire language is like. Since obviously there's infinitely many strings that can be in it, we'll try to describe them in some way. Okay, so I'm going to do 20 and 21. So for 20, the strings start with 1. So they have to start with 1 because you have that 1 first, right there. Okay, and then there are any number of ones and zeros in any order. And then it ends with, or then they end, sorry, I forgot what tense I'm using here. And then they end with 2 zeros, which is these 2 zeros right there. Okay, so you start with 1, then you have any combination of zeros and ones that you want, as many as you want, and then you end with 2 zeros. Okay, so then for 21, what do they look like? So we start with either an x or a y. So the strings start with either an x or a y. So that's from right there. Okay, and then there's a y. All right, and then after the y, you can have any number of x's or y's in any combination or length that you want. Oops, I meant to say and y's. Okay, so that's it. All right, so pause the video and go ahead and try 19, and then check your answer in the back of the book. Okay, so for these, we're going to indicate whether the given strings belong to the language or not that is given by the regular expression, and then we're going to briefly justify our answers here. All right, so I'm going to start with 23. So the expression is x star y or zy star, and then that is all being starred. Okay, so looking at this first string here, I can see that the zyy part, that could come from right here. Okay, but I don't think the xz part is possible because I don't think if you have an x, then you have to have a y after it, right? So, so this is not going to work. So zyy xz is not possible because after any x's, there has to be a y. Okay, and then what about the other one? So zyy, zy. Yeah, I think that's definitely possible because this part can come from here again, and then this part can also come from that. So zyy and zy can both come from the zy star part. So yes. All right, and then for 24, let's look at that. So we have 0, 1 star, 2, and then that's being starred. So that's basically you have a 0 and then any number of 1s, including 0 1s if you want, and then a 2, and then you can just repeat that as many times as you want. So looking at this first string here, I think definitely no. Like they all have to start with 0 and end with 2, right? So that's definitely not going to work. So 1, 2, 0 is not possible because it doesn't even start with a 0. All right, now the other one, so I think this part right here, that can come from this. Okay, and then this part here also can come from that as well. That's if you put the 1 in there 0 times, and you are allowed to do that with the star. You can put whatever has the star 0 times if you want. So 0, 1, 2, and 0, 2 can both come from 0, 1 star 2. So yes. All right, so go ahead and pause the video and try number 22, and then check your answers in the back of the book. All right, so that's it for today, guys. So your quiz next time will probably be like a true-false. Do these strings, can these strings be generated by this regular expression? So I hope you understood that part of it, and that will be our last quiz next time. So next time on Friday there will be another lecture on another computer science topic, but that will be our last quiz. So send me an email if you're having any troubles with anything, and otherwise I'll see you one more time for the last video lecture. Bye bye.